All right, now that I've got these free body diagrams, I can keep cruising. And I'm going to take a look at these 4 locations in more detail to try to get the scale reading. And so when we say scale reads, right, we're saying normal force. What is the normal force at those locations? So I want the scale reading at B, C, and then I need the speed at location D. So let's break this up. We will start at location B, and we'll work to the left, and I'm gonna kind of make some space here. So this is gonna be my space for location B. Let me switch colors. And then some space for location C. And then some space for location D. And I'll work in these 3 columns. Okay, so starting here at location B, right? I have, by the way, some information, which is the speed of the girl at location B. Again, location B, right, is at the bottom of this big dip. Okay, and I'm being asked to find the scale reading, the normal force. So I want my attention to be here. What is the normal force acting on the girl at location B? So I'm going to start with this statement of Newton's second law, which is that the sum of the forces acting in the centripetal direction will be equal to the mass times the centripetal acceleration. But the centripetal acceleration is just the velocity squared divided by the radius. And then I'm going to begin to plug in some numbers. Her mass is 60 kilograms. Her speed was right here, 24.5 meters per second. Don't forget to square that. And the radius of her circular path at location B, for that, I've got to go back up. What's her radius? Well, remember at location B, this is the circular path here. And so the radius is the distance from here to here. Well, we're actually told that is 30 meters. Okay, so that's the radius. And plugging that into my calculator, I get 1200.5 newtons, the sum of the forces in the centripetal direction. I'm going to go ahead and write that up here, 1200.5 newtons. And now I'm just going to look at my picture, okay? So focusing my attention on this diagram. All right, I know that the sum of the forces has to equal 1200.5 up, and I've only got 2 forces that are acting. I have the normal force up and gravity down. So I could write this kind of a statement, that the sum of the forces in the centripetal direction is going to equal normal force minus gravity. Okay, I know that this is 1200.5 newtons. The normal force is my unknown. Gravity is 600 newtons. Therefore, the normal force must be 1800.5 newtons. And if I want, I can write that on my diagram over here. And I can ask myself, does this make sense? So is 1800 minus 600 equal to 1200? Yes, it checks out. The picture makes sense. So I can move on to my next location. Let's go to location C. Okay, so now we're going to focus here. All right, at location C, I have a very similar picture, but now the centripetal force is downwards. Let's figure it out what it is, and then we can figure out what the normal force is. as before, the sum of the forces in the centripetal direction is going to be equal to mv squared over r. The mass is 60 kilograms. The speed now is 14 meters per second at location C. Again, don't forget to square it. And then the radius. What's the radius at location C? So I've got to come up here and notice at location C, we've got a 20-meter radius. So I'm going to plug that in here. And so the centripetal force is 588 newtons. So I'm going to put that in my diagram. This is 588. All right, from this diagram, okay, I'm being told that the downward force of gravity, and I realize that I actually wrote this incorrectly. This should have been 600 newtons. So I'm being told that the downward direction is going to be the stronger force, and it's going to be stronger by 588 newtons. So that tells me that gravity needs to be 588 larger than the normal force. Okay, I can also write an expression like this for location C. The sum of the forces in the centripetal direction will be equal to gravity minus the normal force. 588 down is going to be equal to gravity, which is 600 down, minus a normal force. So the normal force must be only 12 newtons. By the way, where did I get the signs on these? You might be looking at this saying, isn't the centripetal force down, so shouldn't this be negative? And isn't gravity down, so shouldn't this be negative? And isn't the normal force up, so shouldn't this be positive? Sure, that's fine. Basically, I just multiplied my expression times -1, and we have the exact same, mathematical relationship. So if what I just wrote right now makes more sense to you, that's great. But technically, when we're working on these problems, the centripetal direction is the positive direction. So downward, so here for location C, downward should be positive. But if that is unhelpful to you, then you can make downward negative as it normally is, okay? So now we're saying that this is 12 newtons, okay? Why is it 12 newtons? Because check it out, right? So 588 is the total, right? The total of the normal force and gravity. Well, gravity is pulling down with 600, and so if the normal force pulls up with 12, then the difference between them is that 588. Okay, so that checks out. Let's finish up with location D. All right, now at location D, the question is not what is the scale reading, but it's how fast will this girl go through this loop here at location D. We want to find the speed, okay? So I know the scale reading is 273 newtons. So I can actually put that information in my free body diagram. This is going to be 273 newtons, okay? So just by looking at it, I can say, okay, well, 273 down and 600 down is going to be equal to 873 down, right? The sum of the forces in the centripetal direction will just be those two added up, right? I'm just adding those two, 273 and 600. So now I'm getting my centripetal force from the picture, not from my mv squared over r. So the sum of the forces in the centripetal direction is just the normal force plus the force of gravity. This is the 273 and the 600 is 873. Okay, so now I know, now I have this, okay? Once I have that, I can then set that equal to mv squared over r. Say the sum of the forces in the centripetal direction is also equal to mv squared over r, where this is 873, the mass is 60 kilograms, the velocity is my unknown, the radius is, I gotta go to the picture for that. Can I see it up here? Location D, the radius is 11 meters, right? So multiplying both sides by 11, dividing both sides by 60, taking the square root, I get that the speed is going to be 12.65 meters per second. Okay, so let's just review some of the big ideas from this before we close this video. Big idea number one is it is helpful to identify the direction of the centripetal force, okay? It's always going to be towards the center of the circle. So sometimes it was up, sometimes it was down in this situation. Big idea number two is you're going to either use Newton's second law, which is this, centripetal force is mv squared over r, to find the centripetal force, or sometimes you can just use an expression like this from the picture, right? If you know the value of both forces to begin with, then you can just add them up and figure out what the centripetal force is going to be, okay? And that's the basic strategy, is going back and forth between the equation, mv squared over r, and what you see in the picture, okay? So back and forth between this equation and what you're seeing in the picture is the general strategy for solving these kinds of problems.